we designed a weighted distance to differentiate routing trees. The second challenge is that monitoring all routing trees is costly. The resolution is we design clustering algorithm to increase the efficiency. And finally, we design some heuristic filters to mitigate the impact of changes that's caused by normal TCP updates. That's the main routing. That's some simulated events. In summary, we get a high accuracy in some important hijacking scenarios. We have integrated into the BGP World platform. That's just a clip of the web page. We put some information into it that impact ranges such as which prefix, which is unaffected. Please just check the web page. Also, in the detailed information, you can see the paths that's suspected to be malicious. For the second work, that's source address validation. Many of our engineers know this well. That's because the IP address spoofing is harmful to the internet. It can be used to start DDoS attack. It should be filtered when it comes from the source network, or be filtered when it reaches the destination. So we in the research area we call it OSIV and ISIV. The main idea is that we send some SMP packets, some spoofed packets. It should be filtered, and we wait to see the response. And according to the response, we judge, we inference if it's the ISIV or OSIV is deployed. This little detail of the algorithm. First, that's the problem. We send a sync to the target. Maybe the target may be ISV has been employed target network, or no ISV employed target network. They will all, this is a normal. First, we send a normal TCP sync. They all receive this packet, and they will reply with an ICK. And then we send a spoofed packet. It's said it's unreachable. If this for network, it hasn't deployed ISV. This packet was received, and then the target, it won't send retransmission to our providers. But for a network that has deployed ISV, this spoofing packet was filtered, so it can't receive the unreachable message, so it will retransmit the sync SDK packet. So according to this message, we can deduce if it has deployed ISIV. The SMP fragmentation method is similar. First, we send a message. That's maybe, yeah, we send the message to ask the fragment the packet. It may be received or may be filtered, and then we send a normal, a larger packet. If it has received the fragment message, it will fragment the packet and send us maybe 2 packets. But for the network, the targeting the ISIV network, it will reply with the URL length packet. It won't segment the packets. That's the idea. Second, that's the OSIV deployment. We use the routing loops. I think many of network engineers know routing loops. That's that when you send a message to an IP address that's not correctly configured. It's an IP address, maybe for ISB, but ISB it just configured a default routing. Maybe it didn't give this address to any network, so it will be sent out again. So from this scenario, we can deduce how if there is a loop, and also we can induce that the router in the Azure, they haven't do any OSIP filter. That's the idea. So we have deployed this work in our BTP platform. You can check this. You can search for your AS or for your region, for your economy, to see if there is any loop or any OSIP and ISIP information. We want to get feedback from our network engineers because I don't know if routing loop is a major problem for internet because it can used to start some DDoS attack. Also, we refine our dashboard. It is now customizable. You can select, and we include more information such as anomaly information and many information. This is a custom page. And also for some minor refinement, we modified the reverse routing parts showing you can select multi-source, and they are shown in the right bottom corner. So it's easy for engineers to compare them. Also, we have opened the source and open API. You can check and use them. For overall, how we get the data, how we processing the data, we get routing data from views, libraries, and our CTF libraries. And we get our with our data, periodic data, all this we updates every day. And for the data processing, we do real-time anomaly updates. And for the routing path update, prefix update, peers updates, we retrieve routing data at each day and finish the processing about 4 o'clock UTC. And bulking routing updates also we process every day. But for source address spoofing detection, we have to do it regularly. We maybe update it every several months because it's time consuming. For full scanning, it may consume several days. And all the system now are deployed in GCC. They provide some virtual machine for the project. For the route information service, now our CTF routing information service, we have connected with 7 partners. The data sets you can access at this URL. If you will want to connect with us, that's the routing information service, the SA number, and we have 2 collectors. One is incarnate, it's GOCC, and another is CERNET. You can connect any one of these two collectors. You can get real-time updates and historical routing data. Also, we provide some looking glass results, the BGP summary, and some BGP network advertised routes, all this information. For the coordination work, now this system has reached over 300 total users. The last half year, we host 2 ethnic webinar sessions. We are 300 attendees joined the sessions. Also, our team coordinated with GCA on the manners initiatives. We have several meetings, and also we give pre in the manners webinar, and we are collaborator for in all the information. Maybe deliver some information will be shown in the manners observation. Also, we are active engagement with the cybersecurity we are invited to give a pre in the next month, and now we are preparing for this. For the future work, we will research on selective routing policies and non-volley free forwarding, because the internet routing is very complex. We want to expand the multi-vantage point traceable data and get more traceable data collection. And based on this, we want to analyze fine-grained routing paths, and also we can enhance the BGP protocol security. Welcome all our partners or our listeners. Use the system and provide feedback. Use the API, and you can contribute to the routing data resource. Also, you can submit some open source code contributions. We have 2 sessions on Thursday. One is for BGP training. We have video ring engineer from video ring engineers. They will give a very detailed training for the platform. If you have time, you can join us. And also, we have a sharing experience and knowledge sharing session. Some partners from Learn, KST, and from PUR, they will share their experience in using the platform. That's all for the project. Thank you.
Okay, thank you very much for your presentation and sharing the information about the BGP Watch. And any questions from the audience, including the online audiences? Nothing? So one question, did you already detect any abnormalities by using the BGP Watch? Abnormality or misconfiguration detected?
Many users, they have used the, and give to find. I think that's the session our partners from Harnet, they have shown the use monitor, their routing has changed, and so then there may be some delay, some change in the RTT. Yeah.
Okay, thank you very much. So it's almost the time to finish, so I'd like to move to the next presentation. Thank you very much. So the next presenter is Matsumoto-san from the Information Technology Promotion Agency, Japan. And the presentation title is IPA Introduction and Network Build Update. Okay, it's okay. Okay, please start the presentation.
OK です。OK。なんかできる。OK, good morning, everyone. My name is Satoshi Matsumoto from the Industrial Cyber Security Center of Excellence, or ICSCOE, at the Information Technology Promotion Agency Japan, also as known as IPA. It's a great honor to be here today to introduce our activity and share how Japan, through IPA and ICSCOE, is working to advance cybersecurity and build trust through collaboration across Asia. In today's presentation, I will first give an overview of IPA and ICCOE, then explain the background of our industrial cybersecurity initiative, and finally, I'll introduce our international collaboration and future plans, including our effort to expanding our training network in Asia. So IPA stands for the Information Technology Promotion Agency Japan. It was established under the Ministry of Economy, Trade, and Industry, METI, to promote the IT utilization and strengthen cybersecurity in Japan. IPA has 5 core missions. This one is human resource and cybersecurity, and software reliability, and human development, and technology strategy. IPA focuses on training cybersecurity professionals with both IT and OT skill and supporting innovation in AI and digital transformation. The mission to develop cybersecurity professionals with both IT and OT skill is being carried out by ICSCOE. This is mission owner, ICSCOE, Human Development Cybersecurity the expert with IT and OT skills. I'm from here, ICSCOE today. So our our human resource development program, ICSCOE started its training program in 2017 to develop core human resource in industrial cybersecurity. It's a 1-year full-time training program that trains professionals with both operating technology, or OT, and information technology, or IT skills. This mission goal is to build experts who can protect Japan's industrial infrastructure, bring OT and IT to secure critical systems. Our training program also covers management and business aspects. So participants gain a broad understanding of real industrial environments. So these pictures, so our training, the program also participant hands-on and hands-on training and carry out of our simulated real plant test bed in Akihabara. The facility simulates real control system such as factories and buildings and power plants, letting participants learn through attack and defense exercise. The photos below show lectures, group work, and field training in Japan. Also, central picture is our training base in Akihabara entrance. So right side, the participant running in our simulated real plant. So building collaboration, ICSCOE have been working with partners in Japan and overseas to build collaboration in industrial cybersecurity. One example is the JP-US EU Industrial Control Systems Cybersecurity Week for the Indo-Pacific regions. In this program, uh, 38 experts from government and industries across ASEAN, India, Bangladesh, Sri Lanka, Mongolia, and Taiwan participated in discussions and exercise. Another activity is OT security training for ASEAN countries held in Bangkok. This training was organized by ICSCO in collaboration with the ASEAN Japan Cybersecurity Capacity Building Center, or AJCCBC. In addition, ICSCO welcomes government officials from various countries to its exercise facilities in Tokyo. During the International Cybersecurity Workshop, exercise and tour hosted by NISC. Through the activities, ICSCOE contributed to expand global collaboration and to trust in the field in industrial cybersecurity. So this is our facilities network, ICSCOE's network overviews. So our training facility in two sites, one of the Bunkyo site and one of the Akihabara site. And Akihabara site has real simulated plants. So our network is connected to high-speed networks for 400 gig and with IP or DWDM, 400ZR and ZR plus. So high-speed network has been built and activity utilization to interconnected this site. So, and each site is connected to Japan's NLANs. Shinagawa in Shinagawa DC connected to SciNet. So Akihabara site to connected to KDDI Ultimate. So connected to a wide project and HiNet and Fuji XP. And those networks are used to enhance education outcomes and to conduct a wide range of experiments. So in Japan side, expanded to our network to Osaka and Dojima. So via SciNet, thank you. So recently, we have been expanded our network to Osaka. In Osaka, we work in collaboration with CKP or Cyber Kansai project on a range of proof of concept and experimental initiative. At present, our training program are conducted exclusively in Tokyo. The extension of our network to Dojima is a strategic step toward future domestic expansion in Japan. So, based on Japan's national cybersecurity strategy, international collaboration is becoming increasingly important, especially in the Indo-Pacific and ASEAN regions. ICSCOE has been working with many overseas partners on cybersecurity training. Now, to make our program more effective and strengthen collaboration with ASEAN countries, we are building a sharing training and research network across both sides, Tokyo, Hong Kong, Singapore, and Thailand. So we are installed routers. We will install it in early next year, this year, and we will work closely with each region's NLAN to expand our collaboration. In Tokyo, our node will connect to Fuji XP and APAN JP, creating an environment for collaborative cybersecurity experiments in Asia. By doing so, we have to expand the opportunities for joint training and share Japanese industrial cybersecurity expertise knowledge across the regions. For example, participants overseas will be able to access our simulated plant system located in Akihabara remotely, while training in Japan can also connect remotely to overseas training environments for advanced joint exercise. So development status. let me briefly update the development status of end-to-end training connectivity. In Hong Kong and Singapore, uh, the initiation collaboration have already been completed for Thailand. We are training development in February, and we are connected to coordinate the development schedule with Thailand UNET, NECTEC, and Thailand. So regarding international connectivity, the HKJP and HKSG Singapore and the HKSG segments are supported by network paths provided by JUCC and Singapore. For the Japan-Thailand segment, the connectivity is realized via JPIX, BKNX, and Uninet. So Shinji APAN-JP integration. So APAN-JP S7660 on the same physical router with logical system. So this is Hong Kong side, and installed to our routers in Mega I and Advantage data center. Its installation and initial configuration completed January 20. We support and cooperation of JUCC. This photo is our routers. And Singapore installation and initial configuration completed in January 16 with the support and cooperation of Singapore. So our goals, finally, let me summarize our goal and the next step. And our goal is to build a collaborative cybersecurity training network together with endurance and strengthen partnership and trust among Asia countries. So this initiative, we aim to develop highly skilled professionals who can protect critical infrastructure in the regions. As our next step, we plan to expanding participants to more regions and the institutions, ensure stable and secure operation of the network, and establish a sustainable framework for long-term collaboration. By doing so, we hope to contribute to stronger and more connected cybersecurity community across Asia. Thank you.
Okay, thank you very much. Any questions from the audience? Nothing?
I just wanted to ask about this project.
Oh. Okay.
Who funded this project? The project, you just said there are over 30 participants on the project.
This router funded by
Not this page, you can just, yeah, turn back your pages. I think one page you said that you had over 30. Next.
this space.
Just
This space.
yes, yes. I want to know who funded this project. There are many parties.
誰がファンです Sorry, I'm the officer.
It's one of the joint program, Japan, the US, EU industrial control system training. It's funded by those three countries. But mainly is the training in Japan. Then travel budget was something is funded by the Japanese government. And
Thank you.
also is OT security training for ASEAN countries in Bangkok. That is promoted there. AJCCBC is founded, but the back side is Japanese government is a fund to this organization and they collaborate with the cybersecurity training.
Thank you.
Okay, thank you very much. Okay, it's almost time to finish, so thank you very much.
Okay, thank you very much.
And the next presenter said that they want to move to the end of this session, so I would like to skip ahead and move on the fourth presenters. So next presentation is the Miao-san from the Tsinghua University. And the presentation title is RMAP, Uncovering the Risky DNS Resolution Chains and Misconfigurations.
Good morning, everyone. I'm Fa Shengmiao from Tsinghua University, China. My advisor is the first speaker of this session, Professor An. Today, it's my great honor to share our team's research, RMAP, uncovering risky DNS resolution chains and misconfigurations. RMAP, short for Domain Name Resolution Map, is a tool designed to uncover risky domain name resolution chains and misconfigurations. First, before we dive into the presentation, let's take a moment to think two questions. One is, how complex is the process of domain name resolution? The other is, what consequences will arise if the process becomes overly complex? Okay, let's first cover some basic information. Domain names and DNS are the entry points for people to access the internet. The security of the upper layer applications like web service, CDNs, and email relies on the security of domain name resolution. According to the Vincennes research, there are nearly 380 million registered TLD domains worldwide. Domain name resolution involves multiple components, including clients, forwarders, recursive resolvers, and authority name servers. Authority name servers consist of root name servers, TLD name servers, and SLD name servers. Additionally, each level of these name servers compose multi-servers deployed across different different locations, and different components may handle the packets internally. For example, some may drop and some may process because they are handled by different organizations. The multi-component nature makes the domain name system extremely prone to complex and admin like to make configure errors. In recent years, various misconfigurations have caused several major network outages. For instance, in 2021, Facebook suffered an outage of over 6 hours due to this DNS misconfiguration. In 2025, Cloudflare and Amazon also suffered the network outage. Therefore, how to identify and detect potentially DNS configuration errors in advance to avoid large-scale network failures is a common concern in both academic and industry. To address both concerns, we propose RMAP, the first tool of this kind. RMAP can quickly probe all resolution chains of a domain and map its resolution dependency topology. Based on this topology, we can identify and uncover all potentially security risks and misconfiguration without relying on any other data. Admin can also leave this tool to configure their domains. We adopt a module design to ensure high scalability. RMAP consists of four main modules: the probe module, optimization module, story module, and application module. The probe module is the core of RMAP. It can dynamically probe chains from name servers with the key domain, query type, and target IP with a breadth-first explosion. Optimization model with caching to improve efficiency, and it can use a fallback strategy to handle packet loss and oversized response. Story module stores resolution data, including chains, dependency, name servers, and resource records. Application modules can identify risky chains and misconfigurations, and it can assist in domain configuration optimization. We validate RMAP performance using the top 1 million most popular domains. And here is a breakdown of our key findings. For resolution success rate, 84 of top 1 million domains have at least one valid resolution chains. But there is a gap between IPv4 only and IPv6 only. In IPv4 only, 72 domains can have a success rate, but only 18 success rate in IPv6 only. In configuration errors, only 24 of the top 1 million domains are free of configuration issues, and 11 of domains have cyclic resolution dependency. They can make the resolution to loop in a circle, risk of traffic storm, upper service failure. For TLDs, 36 of TLD have potentially security risk in configuration, and we are in agreement with operators to manage these issues. Now let's summarize our key contributions and future plans. First, we develop RMAP, a protectable DNS risk detection tool that operates independently of other data sources. Second, we validate its effectiveness and brought application through the testing on the top 1 million domains. Third, we identify critical vulnerability in major domains and TLDs, including .com and .org. For the future work, we will continue to update and refine our map capability, and we will improve the DNS the society of DNS security. The final is takeaway. Domain name configuration in real-world environments remain highly concerning, and we propose the RMAP, which can provide a critical solution to prevent a large-scale DNS-related outage. That's my presentation. Thank you.
Okay, thank you very much for sharing the interesting work. And any questions from the room?
Okay. Thank you. My name is Basuki from ITB. Yeah. Thank you for your presentation. Let me ask you about the how you measure the with your air map configuration. This the misconfiguration in authoritative or recursive DNS, or you compare like one NS server and with other NS server. So you have a data that you mentioned that only 24% of the configuration is right.
Okay. First, DNS misconfiguration is very critical for the security of the DNS XOR system, and I have identified some misconfiguration in the edu.cn and .com. They can be launched uh, to launch DDoS or hijacking.
Yeah.
I have reported these issues to the operators, and we have engaged with them to discuss the solution to mitigate them.
Yeah, what is the misconfiguration in like in an authoritative DNS like the NS usually in NS1 or not matched with NS2 or NS3 or NS4?
In 2 years ago, and I continue to update it now, and I will improve it later.
Okay, yeah. So I'm interested to compare. What is the missing configuration in like missing configuration in name server 1 or in name server 2 or in the recursive DNS like in the resolver something, which the misconfiguration of this DNS?
Okay. There are so many types before. For example, to send name RS in a packet or oversize the packet and the loop in configuration. For example, A to B, B to C, C to A. This is a circle. Maybe it results in a storm field, and it was the misconfiguration in the DNS packet header. For example, hardcode, AS, and there are so many.
Yeah, thank you. But this is interesting.
Okay, thank you for your question.
Okay, thank you very much. So it's time to finish. Thank you very much.
Thank you.
Okay, let's go to the next presentation, and the next presenter is Putin-san from the Ghazipur Agricultural University in Bangladesh. And the title is Towards an Integrated Network Monitoring to the Architecture and Implementation of Ping Pilot.
Hello.
Okay, please start.
Assalamu alaikum. Hello everyone. Good morning. At first, I'd like to thank to APAN61 for give me the opportunity to present my idea in front of you, as well as I'd like to thank to Brilliant and HIT Project to organize such a prestigious conference in Bangladesh. My today's presentation title is Towards an Integrated Network Monitoring Tool, the architecture and implementation of Ping Pilot. My name is MD Nasiruddin. I am an assistant network engineer at Gazipur Agricultural University, Bangladesh. I previously worked as a network engineer NOC at BDREN, and I have completed my graduations from DUET, Gazipur, Bangladesh. Network monitoring tool. I hope you all know. A network monitoring tool is a software that checks and shows whether network devices are working properly or not. And there are so many network monitoring tools like SolarWinds, Cacti, LibriNMS, Nagios, Zabbix, and so on. And some of those are paid and some of those are open source. However, along with all network monitoring tools, I have created a new one. So the question is why I have developed a new tool. Actually, I thought instead of depending only on existing tool, I decided to create my own solution. So among it, so many network monitoring tools, why can't I have one that I built myself? Actually, I needed a customized tool that could adapt to my specific environment, or where I could add or remove features according to my own needs. So actually, it was an experimental project, and it's all about my passion. But after finishing the first phase of this project, it seems like good and it works fine. That's why I want to share this tool with you. So this is my tool, Ping Pilot. The technology that I have used is Python as a programming language and Django as a framework for Python. I have used PostgreSQL database and Redis as a message broker or caching, and protocol is IP version 4 and SNMP version 2. And of course, in the near future, I will add IP version 6 and SNMP version 3 also. This is the simplest architecture. Here, the main part is Python engine and the message broker, database, and dashboard. This Python engine at first collects IP addresses and community strings and other necessary information from the database. After that, it performs ping operation and SNMP operation. And all the operations performs in parallel mode or asynchronous mode. After completing the operation, the engine collects the result and save to the database. The user views from the database. This is the simplest architecture. But the ping operation takes only 10 seconds to 15 seconds in worst case, and the SNMP operation takes 30 seconds in average. Features of this tool. Obviously, it's Python powered engine, and you all know Python is one of the powerful languages today, and this tool supports around thousands of devices. It checks reachability within few seconds. It supports network scanning and diagnosis. It can track uptime, failure count, latency, packet loss, and more. It can send instant alert when devices goes up or down, and obviously it visualizes real-time and historical traffic graph. It can contain or retains traffic data for 1 year, 365 days, and operation logs for 60 days. and it's easy to use. There is no complex configuration required, and it has web-based dashboard for real-time insights. So now, why Ping Pilot? Actually, although it was an experimental project, but after completing the project, it's really surprised me, and I can perfect result for my own environment, and I thought it can help others institute or others environment. So it can support thousands of devices without requiring any licensing cost. So it's good impact for me, and it's ideal for moderately large networks such as ISPs, universities, or other enterprises. And although this project is an under developing project, I just published my first version of this project. So there is still an opportunity to design the Ping Pilot by gathering feedback from users. I can add additional features by gathering feedback from users. So now I want to show live demo of my project. So this is the minimalistic and simple dashboard. Here I can see total device count, enable and disable devices, offline and online devices. And this is the maximum traffic. This is the monitor tab. This part really helps me a lot. Here the red flagged devices are down, and the below the green flagged devices are up. So here I can see the packet loss, latency, failure count. So this failure count part really helps me a lot, because I can see how many times a device go up or down. So it can help me to detect the device condition, as well as update time and last change. This is the basic parameter for any kind of monitoring tool. However, in this situation, if I want to check any device by manual pinging, I just click on this IP address and then start the pinging, and it's okay. The device is live, and I can trace out also from this part. Okay, so this is the trace route result, and I can refresh. Okay, so you have already hear a sound, a alarm. So because in very recent, 1 second ago, a device just up. So that's why instant alarm. Hello. So this is a monitor tab. So I can check any individual device by click on this button, and it's just check instantly and update accordingly. So this is the monitor tab, and actually I want this kind of view of my for my network, like all the devices will be shown with a single page in tabular form. Okay. So there are additional features like I can ping and test out. I can scan list of range of IP addresses, like one. So here I can scan several ranges of IP addresses. This is the alive list. This is the dead list. So I can detect network devices from here. And this part shows me traffic, interface traffic. So here, download traffic and upload traffic. And if I click on this graph section button, it show me hourly, daily, weekly, monthly, and yearly graph. So this is all about my tools for the first version. So I have already shown it, dashboard, monitor tab, and traffic graph. So my future work is I want to add more informative dashboard in this tool, and automatic device discovery will be added in the near future. And obviously I want to add IP version 6 supported and SNMP version 3 also. And obviously a server resource monitoring system will be implemented. I have already tested it in very soon. I want to add server resource monitoring system with this tool. So thank you.
Okay, thank you very much. Any questions from the room? Okay.
Thank you for your presentation. I am Panaton, student from Gesesa University. My first question is, can you explain what is your specific environment, please?
A specific environment means actually I worked in an university. So in university campus, there are so many Wi-Fi devices, Wi-Fi routers, and some of those routers does not support SNMP. So I just monitor that devices, is it up or down. That's why I need to handle lots of devices like 500, 600, 700 devices. So these features also available in many paid tools like SolarWinds, but SolarWinds is very costly. That's why I build it by myself.
Okay. And the following question is, so if I understand correctly, your application is based on ICMP, right?
Yes.
So basically, your firewall in your university doesn't block ICMP packets, right? So
yes.
what if my university block the ICMP packet, so your application doesn't work, right?
Yes.
So how do you manage, or what do you opinion if I want to use your application in my university?
Actually, there are so many possible options, but I told that it is an under developing project. I can gather the information, I can collect feedbacks from users, and accordingly I can develop it further better. So if I think I want to block ICMP, so I have to find another possible options.
Thank you.
Okay, thank you very much. Okay, it's time to finish. Thank you very much.
Thank you.
Okay, let's move to the next presentation. And the next presenter is Yasukawa-san and Fujimoto-san. And Fujimoto-san is here, so he's from the National Institute of Informatics Japan. And the title is a new ecosystem realized by SPE.
Okay, good morning, everyone. It's a pleasure to be here at Dhaka of APAN61. I'm Yukihiro Fujimoto from National Institute of Informatics in Japan. So today, I would like to talk about the single pair Ethernet. Single pair Ethernet, SPE, while the world focused on the terabit transmission, but we are looking at how to make the last mile of IoT and field science more efficient, sustainable, and reachable. So before starting SPE, I'd like to talk about the traditional Ethernet overview. to understand SPE, we must look at where we are. Historically, IEEE AO2.3 mainstream development was focused on the two things, higher speeds and extended reach. We have seen metallic speeds climb to 40 gigabit and optical speeds reach 800 gig. This is perfect for backbone and high-speed LAN environments. So, but however, the rise of IoT, Internet of Things, has shifted our needs. Devices like sensors and the camera often don't need gigabit speeds. They need a reliable connectivity and power. We are now evaluating metallic Ethernet, moving away from the low speed towards practical application and efficiency. The goal is to reduce cable count by integrating DC power and the communication into a single thinner wire. As you see, currently, IEEE AO2.3 also are studying ultra high speed Ethernet. It's targeting 1.6 terabit PS. It's amazing. But you see, here is the actual working group and the task force in Ethernet. So currently, we have 4 task force. They are focused on the metallic. It's quite interesting. So next, how single pair Ethernet works. So SPE follows the same fundamental concept of power Ethernet, PoE, but it's optimized for single pair efficiency. While traditional PoE requires at least 2 pairs of work, SPE uses power over data line, which requires only 1 pair. It can deliver up to 50 watt of power at 48 volt. This dramatically simplifies the base splitting network required for simultaneous power and data. So the advantage of immediate, the traditional Ethernet system using the category 5 or 6 cables requires 4 pair circuits, leading to a large amount of footprint. SPE reduces this to a single pair, significantly cutting down the number of components and physical space need for installation. This allows us to move from a world where communications and the power requires 2 separate bulky cable runs to a future where they are integrated into a single routine. By meaning these functions, we create a more streamlined and manageable ecosystem for all our devices. So single pair Ethernet consortium, this is to promote this technology. We established the SPEC. Our mission is to formulate, implement guidelines based on the international standards to ensure interoperability, safety, and the quality across all vendors. Our members include equipment vendors, system integrators, and research institutions. To address diverse needs, SPEC defines 3 main categories. Category A for short reach point-to-point system up to 40 meters, supporting needs up to 10 Gbps. Category B for long reach system up to 1,000 meters at
10 Mbps. This is a game changer for large site. Category C for point-to multipoint bus wiring, supporting 8 or more connections over 25 meters. These categories enable a smart infrastructure across cities, buildings, and homes, from social infrastructure like water supply to factory automation and even hobbies. So next, I'd like to show the application for field science networks. Now let's look at the specific application, field science networks. Traditional solutions have serious limits here. Wireless solutions suffer from radio dead zones in dense forests, and the solar power is unreliable in snowy and shaded region. Meanwhile, standard PoE is limited to a 100-meter distance. It's often too short for vast research sites. We are planning to apply SPE to a micro hydroelectric plant in Kamikochi, a strictly regulated national park in Japan. This site has an intake at 1,568-meter elevation connected to a powerhouse 470 meters away. Because it's a protected area, we cannot build a new structures. Any cables must follow the existing water pipe route. So you see here is a detailed map. The elevation drop and 400-meter distance made traditional Ethernet impossible without multiple repeaters, which we can't power easily in the middle of a mountain. We solve this. We are planning to deploy SPE cameras and sensor at intake and the surge tank to allow for remote monitoring. Because the cable are thin and modular, they can be easily repaired if severed by fallen trees or dismantled during the winter off-season. This spring, SPE members will conduct joint field experiments here to further verify these technologies. Here is the actual photo at the Kamikochi project. As you can see from these photos, this is a very deep forest area. The ability to run a single durable cable through these conditions, providing both data for the camera and the power for actuator, is vital for environmental research. In conclusion, SPE is not just a new cable, it's a new infrastructure for field science. It provides operational efficiency by consolidating power and data, ensures interoperability across different vendors, and scales from the micro monitoring to large-scale environmental networks. For research institutions, this is a key component in achieving our sustainable development goals. So this spring, we will actually install this system in the Kamikochi area. So maybe next APAN, we will show the actual challenges and the difficulties. Thank you very much.
Thank you for the sharing the interesting project. And any questions? from the audience? Okay.
Thank you for your presentation. Okay, is there a limitation of SPE?
Oh, this is our experimental study in the next spring. So maybe some difficulty over the SPE might be how we implement in the field. So currently, as you know, IEEE and the Ethernet technology, they are just defining interface specification.
Yeah.
There is no installation method
Oh,
standardization. So maybe this kind of method might be studied in the field.
oh, okay, thank you.
Okay, thank you. Very nice. How about the topological of the SPE? Is there still like a star or bus or can make a ring?
Basic idea of SPE is a point-to-point, but we also take care of a bus topology, point-to-multipoint. So very, very old Ethernet, they are using 10 base 5, for instance. It's almost 40 years ago. The original Ethernet is a bus style topologies. So this kind of topology also supporting by SPE.
Including cascade 1?
Yeah,
or
that's right,
others?
that's right. But we have to take care of power supplying. So because of, bus cascading topology needs more power, DC power.
DC power.
So
48. Still 48?
yeah, still 48, 24, and 12 we take care. But when we are installing by using a bus type of topology, in this case, we have to take care of a voltage drop carefully.
Usually, how long maximum for the 48 for your experiment at SPE?
Okay. As you see, currently, it's much depend on the which transmission speed you are expected. So for 10 gig, for 10 megabps, not a gig, we will support 1,000 meter for a point-to-point. For point to multi-point, it will support currently 25 meter for 8 connection.
Okay, thank you.
Okay, any questions? Other questions? Nothing? Okay, I would like to, I look forward to your future work on the coming coach field. Okay, thank you very much.
Okay, thank you very much.
Okay, it's the final presenter. It's the Sato-san and Motohashi-san from
Hi,
APAN61.
can you hear me? Can you hear me?
Yeah. Very
great.
big voice. Very big voice.
Great. And I guess there's a Kodai as well, so that's Kodai. I can say something, so that's
Hello.
Hi.
Hi.
Okay.
So I'm gonna update the APAN JP. So sorry, we are using the old sites here. Template so that and we have the new mail address after it's the ops@jp.apan.net for the new platform. And so usually we are doing what has happened in the Asian RNA network over the past 6 months. But since we are doing the quite many things and haven't not so much time to summarize all of them, so that we're gonna do the 12-month version in the next APAN, so that we will present it in the hopefully they will be done by the new person in the APAN JP note. So the key highlights of the APAN JP NOC over the last year, so that actually we are done in 2024, so we are doing the SRMBS testing, and we had the APAN Yokohama, and actually we are doing the testing until on that time in the last and the couple of the other things that we had in the following year, so that we will explain one by one. And so the overview of the Asian backbone, so that most of you in Dhaka know that what is the fundamental in the Asian backbone, so that in Asian backbone it's the fundamental backbone is the APONET, so that the APONET is the collaborative resource sharing strength, the resilience, flexibility, and consistency of the Asia Pacific Oceania experimental, so that in short, so that there are numerous organizations who is contributing to this so-called consortium, and they are forming they are providing the backup balance each other, so that we will make great resilience network. And actually there was the JGN has been doing the key role in here, so that the JGN was doing around here. So that they are greatly, they have their presence in Tokyo, Hong Kong, Singapore, so that there is a kind of the most, I would say the most resilient, I mean the most of the cable cuts, so that most of the submarine cable will be cut in the for each submarine cable have the experience 1 or 2 months per cable, so that which means that JGN maintain the resiliency, but with the very little chance for the availability. So they have the nodes in Japan, Hong Kong, Singapore, and the circuit was actually procured in partnership with the JFCC and the NSCC and Singaporean, so that the Japan, Hong Kong, Singapore. And since the JGN is a member of the APONET, so that they have the numerous backup links, so that we have the not the triple, but the quad, not quad, but actually the 5 backup paths. And they provided the resilient layer 2 network, which will be the which has been used by all of these APONET members. So that was the JGN. And the APAN JP, which I am working on, is on top of this. So that so JGN was has been placed on top of the same router as the JGN, so that we had a POP in Japan, Hong Kong, Singapore, and Thailand. And also, so that also we got the backup balance from the members of the APONET, so that we could we have been serving the resilience layer 3 network. And also since Muffin provided the GXP Tokyo equipment, so that we have the exchange point in Tokyo. So this is the equipment from Muffin, so that we are calling it Global Exchange Point in Japan, so which is GXP Tokyo. And the most Japanese academic networks and some international networks are connected to the GXP Tokyo. So and we have the connected to the Fuji XP, which is a new exchange point in Tokyo, and connected on the July 7th. And let me skip that since we have not so much time. But the important thing is that we have migrated this APAN JP network to MPLS-based network, so that we can accommodate layer 3 and layer 2. So that was our plan. And actually we have migrated our layer 3 network on the March 2025, and it was quite painful, but we have done it in 1 day. And also we have started the layer 2 VPN as well, so that starting with the GP4L, Jant P4R VLAN, and it went successful since, and then we are quite confident that it will work. And then we had the news from the NICT. So that the JGN, and this is the website, so that the JGN has ended its operation on the December 26th of 2025, so that we lost the layer 2 resilient layer 2 network on this time. And also we lost the LHC1 via JGN, so that the numerous NVN has been connected to the LHC1 via JGN. So that we will lose it in December. We are about to lose. So that I want to give the Toda-san in there, so that please give a round of applause for the NICT for now, so that and so we are forced to migrate to the new backbone. So that the impact of the JGN withdrawal was the disappearance of the layer 3 network of APAN-JP, which is since the APAN-JP on top of the JGN, and the disappearance of the layer C1 connectivity via JGN, and the loss of the automatic rerouting, which loses the resiliency in this region. And so this was the APAN-JP backbone in 2025. So that we are connecting the quite the with the well, it is on top of the JGN router, so that we had the quite many cross connect in Hong Kong and Singapore, and since we're gonna lose them, so that we are quite confused. And then so there's a circuit, so that each organization has a circuit. Then the first thing is that we could do the connected to the layer 2 box in each location, so that in Singapore, so that should be the SOE, and in Hong Kong, that will be the HQS, which is provided by the JUCC. So that is the first idea. But since those boxes is actually the just layer 2 box, which means that we will lose the resilient network on this case. So that but the important thing is that these local exchange points have the connectivity that is connected to the JGN. So that if we could so that if we migrate to its layer 2 box, then we have at least have the connectivity without the resiliency. And actually we have a current in January. So we wanted to have the router in here, so that we could have the SRM PLS, and then we have the resiliency, so that we look around and the IPS setup, and so IPA, so that he's actually sitting in front of the room, so that I can see Kobayashi-san and Matsumoto-san, so that they worked very hard to obtain not 2 but 4 of the router in Tokyo, Hong Kong, and Singapore, and Taiwan, and then they got the router, and now there was the question of where should we put the router, and we contacted JUCC and Singering, and then generously they agree to that we will place a router in their rack. So that was the 2025, and now this is the current backbone. So that we placed the IP router in the JVCC rack and the Singapore rack in the last 2 weeks ago, so that it is up and running. And then for the LHC1 peering, so that we had migrated to the APAN-JP as the AS7660, so that it had to be migrated from the JGN to the APAN-JP. And so we're gonna skip this since we have the 1 minute. So that so this new project will be handled by the JUCC, Singaren, and the SINJI, which is the coalition of the Interpret Network for Japan and international. So SINJI is the kind of the coalition of the all of the Japanese NREN. And so the migration to new backbone has been done, so that the migration to the exchange point done in the last December, and we have placed a router in January, and we will place a router in Thailand in next month, so that we will complete the migration pretty soon. And the current progress of the migration is this, so that we have completed Singapore and the Hong Kong. And that's it. Thank you. And also, Kitagawa-san, thank you for sharing.
Okay, thank you very much. So, any questions? Or do you have any? Okay.
Thank you very much, Sato-san. My name is Koji Toda from NICT
Thank you.
Japan. As Sato-san mentioned, NICT will withdraw all the procurement, Singapore, Hong Kong line, and Thailand and Singapore line. But these lines are maintained by Singapore and JCC and cooperation of KDDI or IPA and so on. So this is because we will extend the test bed for application layer research such as AI and neural network and beyond 5G and so on. But we would like to contribute to the APAN activities. So we hope that we would like to collaborate with each other from now on. Thank you.
Thank you.